And is that going to be a solid line or a dashed line? Solid line. Is it going to shade everything above or below that line? Very first one. Is it? I don't know. You tell me. What does that say? If you guys are struggling on that, you better get a handle on that before Thursday.
Oh, below?
Below.
Extra to the
Mm-hmm. Yep. That y is positive, which means that sign's not going to flip around. So it's everything below that line. If you're not sure, then you need to put it in slope-intercept form. But then we would have gotten y equals negative x plus 5, so that shades everything here. Yep. I'm just doing an example problem that you can reference when you're doing your linear programming project. Okay, how do I graph x is greater than or equal to 2? What kind of line is that?
Like this.
Huh? What is that way, Hannah?
To be honest, I'm not sure of the name, but I always just,
What is it, Marin?
vertical.
Vertical, yes. So you go to 2 on the x-axis. Is it going to be a solid line or a dashed line? Solid line. Whoa. And it's everything to the right. And I'm only going to do the part that's already overlapping with that triangle. And then how do I graph the last one? Y is greater than 0. What kind of line is that? Horizontal where? Right on the x-axis. Is it solid or dashed? Solid is everything above that line or below that line? Above that line. So everything in here. So that triangle now is your feasible region, right? So this is the feasible region. So within that, how many points do you need to be concerned about to find your maximum or your minimum? 3. How many vertices are in that shape? 3. You have 3 corners on a triangle, right? Points on a triangle. So you're worried about this point, and this point. And you need to find those coordinates. Can you find those coordinates without doing anything mathematical besides counting? Yes, you can. So the bottom left coordinate, what are those? Where are the coordinates to that point? 2, 0. What about the one to the right? 5, 0. And 2, 4. Okay. So how many points are you going to test in order to find your maximum output? All 3 of them. Yep. So now you need your objective function. So what I would do is just right below that, you're going to test f of 2, 0, f of 2, 4, and f of 5, 0.
Oh, and then
And-
we just plug those in.
Exactly.
Okay, I get you.
So now you would do 5 times 2 minus 2 times 0, which would give you 10. Let me scooch this one down a little bit. 5 times 2 minus 2 times 4, which would give you 8. Oh, no, sorry, it gives you 2. Yeah,
No, isn't it 10 minus 8?
yeah, so it should be 2. I wrote 8. And then f of 5, 0 would give you 5 times 5 minus 2 times 0, which would give you 25. And then you need to write maximum at 5, 0. So you have 3 of those problems on that part 1 that have to be done by hand. If you do not have the capability to scan that part of your work and Dropbox it to me by Sunday night at midnight, yours is due Friday. If you bring it to me Monday, it is late. So however you have to get that done, that needs to be to me by, if you have no access to a scanner, I don't want to hear about it after the fact. If you need to turn that hard copy in, hard copy, then it needs to be in here by Friday. If you have the ability to do it by hand and scan it and email it to me or Dropbox it to me, that is fine. But if you don't, better get a handle on that now. Logan?
For the project, we have to do all three of the things like A, B, and C.
Yes.
Great.
Great. Well, what did that problem take us? Maybe 5 minutes? Okay. Okay. Yes?
Can you like just take a picture of it and send it to, like,
No, I want it on graph paper.
well, no, I know, but can't, like, Dropbox it to you, can you just upload a picture?
It needs to be legible. If I get something that listen to me, if I get something that I can't read, I'm not giving you credit for it. So make sure whichever way you send it to me, it's clear and legible that I can see it. And I can clearly see your points and clearly see your graph. Okay? All right, so down below, I have, wrote over it, sorry. Okay, now on the part 2 of your project, I gave you 6 scenarios to choose from. You need to choose 2. This is the part that you can do the graphing on Desmos. Okay, and you can, do you guys know what the snipping tool is on Windows?
Showed us.
It's awesome. It's the best thing ever. I'll show you in a second off the computer. Okay, so, furniture, and so this is an example. You need to pick 2 off of the list that I gave you to do and do the same thing for both. So these are the steps you're gonna do. A furniture company produces tables and chairs. So in my world, I'm gonna call those T's and C's, because it makes it easier for me. Each table requires 1 hour in the assembly center and 1 1/3 hours in the finishing center. Each chair requires 1 1/2 hours in the assembly center and 1 1/2 hours in the finishing center. The assembly center is available 12 hours per day, and the finishing center is available 15 hours per day. Let X and Y, I'm gonna call them T and C, be the numbers of tables and chairs produced each day respectively. So find a system of inequalities describing all possible production levels and sketch the graph of the system. So what I asked you to do was first set up your inequalities. So what are your constraints? What are you limited by in this situation? What? 12 hours in the assembly center and 15 hours in the finishing center, right? That's all you've got. So first thing you're limited by is in the finishing center. Does that have to be greater than or equal to 12 hours or less than or equal to 12 hours? You can't work over 12 hours, right? So it can be exactly 12 hours, but it can't be over that, and the same goes for the finishing center. How much time does what are you making in the assembly center? Chairs and tables, right? So they're both going in there. How much time does a table require in the assembly center? 1 hour. So I would call that 1T, 1 hour per table. How many hours does a chair require in the assembly center?
1 and 1/3.
What?
1/2.
Yeah, 1 1/2, so 1.5 C. He wants to be brave enough to try and tell me what my assembly center equation or inequality is going to look like. Wow. Way to be brave, children. What is this? What does the 12 represent? Which center?
The assembly.
What does the 15 represent? Finishing. Okay, so now tell me how many hours a table requires in the finishing center and how many hours the chair requires in the finishing center, Maria?
1 and 1/3 hour for T.
So can we call that 4/3? Is that okay with you? Well, it just might be easier when we go to graph it. We'll call it 1/4. That's okay. And then how many hours does the chair require in the finishing center?
1 and 1/2.
1 1/2. Okay. Is there any other constraint that's going to be going on? Can you make negative chairs or negative tables? So what's another constraint? How am I going to write that mathematically? Machu. What? Tables have to be
Greater than or equal to 1.
Can you make no tables or no chairs?
Nope.
Is there anywhere in there it said that I had to make I had to make a certain number of tables or chairs? No? So it just has to be greater than or equal to 0. I can make no chairs. I can make a bunch of tables with no chairs. I can make a bunch of chairs with no tables, because I'm trying to figure out how to maximize my time, right? Ooh, Dankeschön.
From Paula, I steal from
I
her.
know. It's okay. Okay, so how many lines should you be graphing when you go to graph that? 4. You should have 4 different things that you're graphing. So once you do that, this is the point that I would go to Desmos and graph that. So somebody's gonna have to read back those equations to me.